Development of gas transportation of liquefied gases by sea, it started even in late 20s. Transportation of liquefied gases in bulk. In the very beginning, of course, we were transporting only propane, butane, and that also in a fully pressurized tanks. It is as simple as what we use the LPG at home. The cylinder is also fully pressurized at ambient temperature. Now, around 1959, semi-pressurized ships entered the market and liquefied gas was now transported under lower pressure, which was made possible by lowering the temperature. So of course, from those days, the research was on that how to liquefy the gases, how to liquefy other gases for transportation, because it's very simple. If I have to transport gas in a gaseous form, we need much more space as compared to when we transport in a liquid. I think it's about 600 to 650 times less space we require when we transport these gases in a liquefied form. Now by 1963, fully refrigerated ships for LPG, LNG, and certain chemical gases were in service, carrying cargo at atmospheric pressure. Now, liquefied gas, if you see, is divided into different groups based on their boiling point, chemical bindings, toxicity, flammability. And these different groups of gases have led to different types of gas carriers. Cargo containment system for gas carriers. Now it is, if you see this bulk transportation of these gases, again, it is controlled, it is regulated by our gas carrier code, IGC, what we call. And this is the whole research has been put into this, what type of materials to use for the tanks, especially when you are carrying at say high pressure. Then of course the wall thickness of the tanks have to be thick. If you are carrying at very low temperatures, the material should be such that it can stand so much of temperature, like in case of LNG, which is transported at minus 160, minus 161. So definitely these materials must be specialized. So this is how the research was on, and finally today what we see, this gas transportation, it looks not so difficult after all the technology has been put into it. For economical marine transport, of course, gas carried in liquefied state, and as a liquid, the volume to weight ratio at atmospheric pressure in the range of 650 times less than in the gaseous state. So that means we can carry 650 times more cargo in liquid state as compared to carriage in gaseous state. And again, the temperature, the pressure which go on, or all the gases which can be condensed. So temperature at which a gas condenses is a function of its pressure. And combination of pressure and cooling is therefore fundamental to gas carrier design. Now some ships carry gases liquefied under high pressure. Other ships carry these gases under refrigeration, low temperatures. So certain gases cannot be liquefied even under high pressure, but when you lower the temperatures, they can be liquefied. So most significant cargoes in terms of tonnage, of course, methane, what we call LNG, it's mostly methane, LPG, butane, propane, and mixture of these, and ammonia. Now other cargoes of commercial significance, butadiene, ethylene, propylene, and vinyl chloride, which is used for your PVC, manufacture of PVC. And apart from ethylene and methane, all these gases can exist as liquids at normal ambient temperature. So that is the best part, that is the temperature doesn't affect, but under high pressure. So therefore they are transported in highly pressurized cargo containment systems at any temperature up to the highest expected ambient temperature. The critical temperatures for ethylene and methane, LNG, if you see, are below normal. LNG, I told you, I think it's minus 160, minus 161. It is difficult to even imagine what will be the temperature of -161. You are carrying a liquid at such a low temperature. So you definitely need the ship's design, the system, the equipment, the gauges, the sensors, the pumps who can withstand this low temperature, and of course the dangers associated with such low temperatures. The carriage of ethylene, ethane and methane requires semi-pressurized or fully refrigerated cargo containment systems. Now, these considerations of course led to the following options: that certain gases can be carried in a highly pressurized vessels, certain gases can be carried in refrigerated, certain gases semi-pressurized or fully refrigerated. So these are the gases. That's why these, you see the different type of ships, because all these gases cannot be carried out in the same ships. Some need fully pressurized, some semi-pressurized, and some need fully refrigerated. So this is what we will see, the various types of gas carriers. They are based only on these properties, that these gases are to be carried in these type of ships. Now comes the materials. Materials exposed to liquefied gas cargo should be resistant to any corrosive action of gases. And for this reason, if you see, the copper alloys, brass have to be excluded from the cargo systems of ships. And details of these materials of construction which should not be used, again chapter 17 of IGC code. Now this code is again a very nicely written, that properties of these materials and how they react and what they can do. So during construction they take care of all this following the IGC code. Now some basic definitions. Of course, guys who are not working, gas as per IMO for the purpose of its gas carrier codes. A gas is a liquid with a vapor pressure exceeding 2.8 bar absolute. Now, at a temperature of 37.8 degree or 100 degree Fahrenheit, if that anything, the liquid which is having a vapor pressure exceeding 2.8, they call it a gas. Boiling point, the temperature at which the vapor pressure of a liquid is equal to the pressure on its surface. Simple. Or is the temperature in which the vapor pressure of a liquid becomes equal to atmospheric pressure. Cargo area, of course, we are all familiar. Cargo area, any ship, especially tankers and all that you have seen. Now this cargo area is a dangerous part. Anything, gases, flammability, anything is present there. So part of the ship which contains cargo containment system, cargo pumps, compressor rooms, and includes deck area above the cargo containment system. Cargo containment system is basically your tanks, cofferdams, ballast tanks, void spaces, and after end of the aftermost hold space or forward end of the forwardmost hold space excluded from this cargo area. So cargo area where all these things, basically your cargo tanks, pumps, pipes, compressor rooms, and this area definitely will be hazardous area. Cargo containment system, arrangement for containment of cargo included, where fitted primary, secondary barriers, associated insulations, inter-barrier spaces. So this is what we call the cargo containment. It's like a thermos flask, no? You have primary barrier, you have secondary barrier. So the temperature should not affect, and in between you have a insulation. Gas dangerous space or zone, or a space or zone within a ship's cargo area which is designated as likely to contain flammable vapor and which is not equipped with approved arrangements to ensure atmosphere is maintained in safe conditions. Any ship we have, whether it's tankers, product, chemical, so all these areas where these vapors, gas vapors are present, we declare them as a gas dangerous zone, and gas safe space which is designated as a gas, not a gas dangerous space, where we can, like your inside accommodation, of course we have certain spaces, otherwise smoking and all that is not permitted. So only on the non-gas space where no gas exists, those areas are considered safe. Hold space, these are the terms which very frequently used in your gas carrier designs or gas carrier code, the hold space is enclosed by the ship structure in which your cargo tanks are basically kept. It's like cargo hold and you keep a structure or a tank inside the cargo hold. So the space between your tank and the ship structure, that becomes your hold space. Interbarrier space between primary and secondary barrier. So it's very simple if you see from the sketch also. MARS, another term, abbreviation for maximum allowable relief wall settings. So normally all tanks have individual relief walls in case the pressure exceeds. So these wall settings are even mentioned in your COF that all these walls for these cargoes are set to be set at, उनकी setting जो है, it is at a particular pressure. Primary barrier, the inner barrier space or the inner surface designed to contain the cargo. And secondary barrier, basically the liquid resistant outer element of a cargo containment system designed to provide temporary containment of a leakage of liquid cargo through the primary barrier. So these are the idea of, in case basically to contain the cargo. In case of primary barrier there is a leakage, so it should not go out to sea. So the secondary barrier, which is basically a hull design, hull structure, that will stop this cargo. So a normal tank, like I told you, it is first is the inner space where you load the cargo. This becomes the primary barrier, the inner coating. Then you have the insulation, steel cladding, and then the secondary barrier is your again the hull. So in case the cargo leaks from here, so again it will not go out, it will remain into this what we call the secondary barrier or the hold space. Tank dome, very common tank dome we see. And these gas carriers, if you see, it is not permitted for cargo pump room to be placed below the upper deck, nor maybe cargo pipelines be run beneath the deck level. So therefore the deep well or the submersible pumps must be used for cargo discharge. Pipelines to cargo tanks must be taken through a cargo tank dome which penetrates the deck. So these tank domes are basically used for all your pipelines, everything which is running. So there is nothing the under deck what we have on a liquid carrier or a cargo oil carrier where the pipeline pump room is all down below. Here everything runs through this tank dome. Now comes the hazards. So what are the basic hazards which are associated? ये भी आपका common question है. Basic hazards with the gas carriers, and then some questions on the equipment, reliquefaction plant, or the various types of gas carriers. Now सबसे पहले let's see personal hazards. Flammability. Of course, when we are carrying these gases, most of the gases are flammable except ammonia and all which needs little more higher energy. But the moment this liquid gets converted into vapor mixed with the oxygen, so flammability is the first thing for any liquefied gas. Toxicity, yes, poisoning, asphyxia, low temperature, frostbite. Now if you touch this liquid such a low temperature or the vapors which will be again at such a low temperature, it can burn the skin, what we call like the frostbite. Immediately your cells die. Chemical burns, of course, we all know. Now flammability, if you see, single most hazardous aspect of liquefied gas is the flammable nature. All liquefied gases transported in bulk by sea, with the exception of chlorine, are flammable. Vapors of all these liquefied gases very easily ignited, because the moment the pressure is reduced or the temperature goes up, the liquid itself gets converted into the vapor, and vapor mixing with oxygen, simple, catching fire. Now, exception to ammonia, of course, which needs little more higher ignition energy, and accordingly fires following ammonia leakage are less likely than the other cargoes. Now, emergency aspects. If you see this, even on the ship, even on the terminals, now we all know these gases are highly flammable. So the areas are declared basically the ignition free zones. Why? Because of the very rapid vaporization of this spilled liquid gas. Now it is in a liquid form. The moment it comes outside, the pressure is reduced. Temperature, if it is carried at low temperature, the temperature goes up, it gets converted into vapors. And the spread of this flammable vapor will be far more extensive than in case of a similar spillage of oil. So chances of ignition following a spill of liquefied gas is much greater. For this reason, of course, your terminals, ship, everywhere we take definitely extra precaution that yes, no ignition, no sparks, no flames, no smoking at all. And radiation from these liquefied gas fires, because of the rapidity of vapor production, it can be intense. And we cannot do firefighting like a normal case, that in your normal clothing. So you have to be wearing a protective clothing because fire extends very fast. And the radiation from this fire can be intense. Toxicity. Of course, some cargoes are toxic and cause temporary permanent health hazard, such as irritation, tissue damage, impairment. And toxicity we have seen also in case of chemical tankers also, or even toxicity is today everywhere, even in crude also. Some crudes have the toxic effect and they can enter through your skin also. Or open wound contact, inhalation, ingestion. All these things we have gone through, how the toxicity effects. So this here also the same danger exists. Contact with cargo liquid vapor should be avoided. Protective clothing, and in case required, breathing apparatus and toxic gas detection equipment also should be used as necessary and should be properly maintained. Now next is asphyxia, basically is suffocation. Now when these gases are present, so what they do when they're excessive of these vapors are present, there will be definitely reduction in oxygen. And we know that the human body requires 21% oxygen for survival. However, in a gas-free atmosphere, somewhat less oxygen can support life for a period without ill effects being noticed. But less than that, the susceptibility of persons to reduced oxygen levels, it varies person to person, but at levels below 19%, you find the person is behaving absolutely different. There's a mental confusion when the oxygen level is, say, about 19%. He may not be able to appreciate the predicament. He may not be able to appreciate what is happening around him. So we may think that he is okay. But in reality, he is basically suffering from the lack of oxygen. And of course, below 16%, chances of survival are less. Unconsciousness takes place rapidly. And if the victim is not removed, permanent brain damage. So these are the very basics. We have all studied in the Medicare courses and all that yes, how there's the oxygen effect. Here also, if more of these cargo vapors are present, so there will be less oxygen. Now in general, such a problem is limited to enclosed spaces. Oxygen deficiencies in an enclosed space can occur due to any following reasons. When large quantities of cargo vapor are present, large quantities of inert gas or nitrogen are present, oxygen deficiency will be there, or rusting of internal tank surfaces has taken place. So all these things, now when you know the presence of cargo vapors or inert atmosphere, it is understood that there will be a deficiency of oxygen. So for above reasons, it is essential to prohibit entry to any space until oxygen content is 21% is established. And of course, we know how to check the O2 content and all these things. Anesthesia. Now these gases have got that anesthetic effect also. Inhaling certain vapors, for example, ethylene oxide, may cause loss of consciousness due to the effect upon the nervous system. So we all know sometime in the life we have gone, the doctors inject this anesthetic, either local anesthesia or general anesthesia. Basically, your nervous system becomes basically doesn't feel anything. The unconscious person may react, but can only be roused with great difficulty. So anesthetic vapors hazards can be avoided by use of cargo vapor detection equipment, breathing apparatus, in case you have to work in that area. Frostbite. Another danger with this extreme cold liquefied gases, when we carry at low temperature, the extreme coldness of some of these gases itself is significant hazard. Now, sometimes you may have seen engineers also suffer when they touch these freon pipes in the refrigeration system. So those pipes are at such a low temperature that it gives this frostbite is something like a burn. So if the skin is exposed to severe cold, the tissues become frozen. This danger is ever present in gas terminals and on a ship handling fully refrigerated cargoes. Symptoms of frostbite: extreme pain, affected area, confusion, agitation, and even possibly fainting. Shock if effective area is large. Initial symptoms is very simple, like frostbite. On normal ships we don't experience this. Only chances are when you touch this very extreme, this refrigeration or air conditioning where these low temperatures are existing, the skin initially becomes red, but then it turns white. And affected area is usually painless, and affected area is hard to touch. And again, if it is left untreated, the tissues will die, and there's something called gangrene. And if the gangrene sets in, to save, because it spreads very fast, the tissues start dying, so that particular portion of your body has to be amputated to save the life. So frostbite is not a simple thing. It's not like just a burn and okay, हम कुछ लगा के we will recover, or the part of the body will recover. So here, if this gangrene sets in, very common in extreme high altitudes, even the army people who are serving at the Siachen and all that, very common there. Extreme cold, frostbite is very common in winters. So treatment is warm the area quickly by placing it in a warm at 42 degrees until it is come to normal temperature. Keep the patient in a warm room. Do not massage the affected area. We have a tendency, अच्छा cold burn हुआ है तो चलो इसको थोड़ा सा massage. No. Severe pain may occur on thawing, and give a painkiller or morphine if serious. Blister should never be cut, or clothing removed if adhering firmly. And of course, simple dress the area with sterile gauze, and area doesn't regain normal color sensation, immediate medical advice, because if it remains white means the cells are dying. So this is the very hazards and the immediate what actions we are supposed to do. So hazards तो हमें पता है, उसके साथ साथ थोड़ा सा उसका rectification ये भी है कि yes, sometimes they ask you yes, what are the hazards and what all measures you can take. So immediate action necessary without warm water close in hand. First instance, the affected part can be warmed with the even body heat or urban material. Now
gas carriers के ऊपर ये warm room होता ही है सर?
दो वार्म रूम मतलब रूम तो अपना नॉर्मल टेम्परेचर है, अपना एनी रूम अगर आप ले लीजिए, एसी वेसी बंद कर दें तो आई थिंक शिप पे तो वी हैव इनफ normal temperatures. These rooms are there. There's nothing or special warm room, but in case something happens, a person gets exposed, or if you touch that liquid, or you come in contact with these low temperatures, extreme low temperatures, because you see जिसमें ये liquid gas चल रही है, even the pipeline and all that, that will also be at so low temperature. So उसका immediate है कि yes, immediate action is कि it's very basic. See, we all study. अब हमें कि yes, we are not in the hospital. Daily तो हम ये काम नहीं करते. पढ़ हम जरूर लेते हैं कोर्सेज में, चाहे आप मेडिकल ले लीजिए, मेडिकल गाइड है, बुक है, उसको खोल लें. बट ये तो एक किस्म की if you ask me, this is a very simple thing like a first aid. So ये हमारे माइंड में इमीडिएट होना चाहिए, बिकॉज द फर्स्ट कहते हैं ना 2-3 मिनट्स हमेशा लाइफ के लिए, फर्स्ट 5 मिनट्स आर इम्पॉर्टेंट, फायर के लिए भी और लाइफ के लिए. वहाँ पे ये एक्शन ले लिया तो यू कैन सेव दैट बॉडी पार्ट. फर्स्ट पार्ट तो है कि यस, अगर इमीडिएट एक्शन या मेडिकल एडवाइस अगर मिलती है, शिप में तो मेडिकल एडवाइस इज लिटिल नॉट सो इजीली अवेलेबल. तो यही बेसिक चीज़ें हैं कि यस, जैसे उसने कहा कि इसको वार्म रखिए इमीडिएटली, एंड डू नॉट मसाज, और उसके ब्लिस्टर्स वगैरह को नहीं कट करना. एंड टेम्परेचर आता है, स्किन नॉर्मल आ जाती है तो ठीक है, अदरवाइज इमीडिएट मेडिकल एडवाइस इज द सोल्यूशन. Chemical burns, of course, ammonia, chlorine, ethylene oxide, propylene oxide, Chemical burns का भी, if you see the symptoms similar to the burns by fire, except the product may be absorbed through the skin. Chemical burns में तो yes, they can enter through the skin, they can enter through your eyes or anything. And chemical vapors, we all are very well aware, is particularly damaging to the eyes. Chemical तो हमेशा हम कहते हैं chemical गया उसकी eye में, first thing comes कि उसकी eyes गई है. So these gases also, when they are in liquefied form, they have the same effect. Burning pain, redness of skin, irritating rash, blistering or loss of skin, toxic poisoning. So ये सारे symptoms आपके with the chemical burns के साथ. अब इसका भी treatment, attend first to the eyes and skin. Wash eyes thoroughly for 10 minutes with copious amount of fresh water. Skin, wash the skin thoroughly for 10 minutes and cover with sterile dressing. अब इस चीज के लिए है कि yes, when you are carrying these gases, immediately we cannot rush. So therefore, most of these gas carriers, they have these deck showers, eye baths on deck very easily at very convenient place. That something happens immediately. So water is the best solution. Copious amount of water you use for your eyes, anything. So to save उसका effect को nullify करने के लिए. अब पर्सनल हैजर्ड्स को छोड़ के अब आगे आपके अदर हैजर्ड्स, ये भी कार्गोस हैं, ये भी गैसेस हैं, लिक्विफाइड फॉर्म में हैं. सो फर्स्ट ऑफ ऑल इज द रिएक्टिविटी. नाउ लिक्विफाइड गैस कार्गो may react number of ways with water. अब ये जो कार्गो है, if you have a water, now you can imagine if I am carrying a liquefied gas at a low temperature, अगर उसके अंदर पानी हुआ तो it will freeze. So what we call in this is the formation of hydrates. And if a small amount of water, if you can imagine in a liquid, if you have something frozen like hydrate or something like ice, so it can be damaging. Pumps, after all liquid को हमने pump के through निकालना, so pumps, anything, it can be damaging. So therefore the reactivity hazards can be with water, can be with itself, with air, another cargo or other materials. So let's see what are these hazards with the reactivity. The reaction with water, first we call it the hydrate formation. Some hydrocarbon cargoes will combine with water under certain conditions to produce a substance known as hydrate, resembling crushed ice or a slush. And water for hydrate formation can come from purged vapors with an incorrect dew point, or water in the cargo system, or water dissolved in the cargo. So normally this care is taken before the cargo is processed or supplied, that there is no water in the cargo. Other liquids we have seen, tankers we can accept, so cargo में पानी आया, it will separate and settle down. But यहाँ पे तो it is not going to settle down, it is going to even get converted into a very hard ice. Hydrates can cause pumps to cease, equipment to malfunction. Care should therefore be taken to prevent there is no hydrate formation takes place. Certain cargoes, like notably LPGs, may contain traces of water when loaded. Now, it may be permissible in such cases to prevent hydrate formation by adding small quantities of antifreeze. But again, we don't normally do it. Now they say yes, it is possible, but it is done by the terminal. They will do it because nothing whatsoever should be added to any cargo without shipper's permission. So he cannot, otherwise his cargo may go bad. What he has loaded, he may not get something. So possibility is there to save this. Yes, if the cargo contains कि भी इसके अंदर थोड़ा बहुत पानी के traces are possible, then they should rectify it. They should put antifreeze and supply so that we don't face any problem with our equipment. Self reaction, ये भी हमने जैसे chemicals में पढ़ा, certain cargo, certain these liquefied gases, they may react with themselves. And most common of self reaction is again polymerization, which may be initiated by the presence of small quantities of.
सर ये पानी का इनिशियल गेजिंग के टाइम पे पता चलेगा ना सर?
Yeah, normally you see पानी का ये है कि yes, when we carry out this लोडिंग, सो उसी वक्त है कि हमारी जो टैंक की जो प्रेपरेशन है, फर्स्ट ऑफ ऑल हमारे टैंक्स में कि उसका भी गैस कैरियर्स के लिए लॉट ऑफ प्रोसीजर्स। अब बाकी टैंकर्स में तो ठीक है, हमने इनर्ट किया और चलो लोड करो कार्गो और चलते हैं, बट यहाँ पे देयर लॉट ऑफ थिंग्स आर प्रोसेस्ड। ये आपको टैंक्स को आपने इंस्पेक्शन की है, उसकी ड्राइंग अप ऑफ द टैंक्स, गैसिंग अप द टैंक्स, उनकी टेम्परेचर। इमेजिन आप नॉर्मल टैंक्स, आपके शिप अगर नॉर्मल टेम्परेचर पे है तो उस टैंक्स में मेरे को लिक्विफाइड गैस लोड करनी है से इवन 100 डिग्री पे, -100 पे या -50 पे, सो आई कैनॉट लोड इनटू द नॉर्मल टैंक्स, तो उसका टेम्परेचर हमें नीचे लेके आना पड़ेगा। सो वी हैव टू कूल द टैंक्स, कूलिंग एंड देन गैसिंग अप, एंड उस दौरान हमारे टैंक्स के अंदर whatever we inject, even sometimes we inject this inert gas इनर्टिंग के लिए, तो वहाँ पे भी वेपर्स नहीं होनी चाहिए। तो वेपर्स जो हैं अगर वो कंडेंस होकर वाटर फॉर्म करते हैं तो नेचुरली कार्गो आएगा, तो टैंक में तो ऑलरेडी चाहे आप फ्यू ड्रॉप्स ही कह लीजिए पानी तो है, तो वो सारी चीज़ों का प्रोसेस है। दैट्स व्हाई यू सी द प्रोसीजर्स दैट वी कैरी आउट बिफोर लोडिंग। तो ये सारा का सारा है कि यस, एंड सेम थिंग इज अ टर्मिनल, उन्होंने भी जो कार्गो स्टोर किया हुआ है, सो दे हैव स्टोर्ड इन सच अ केस दैट देयर इज नो वाटर इन दैट। तो ये सारी प्रोसेसेस दे टेकन बिकॉज लो टेम्परेचर्स कार्गो के लिए तो ये प्रॉब्लमेटिक इशू है ही। सो यू विल नॉट फाइंड,
अगर हमारी तरफ से निकलता है सर तो फिर हम ड्राइंग करेंगे उसकी पहले,
या
है ना?
या नॉर्मली देयर इज अ प्रोसेस कि उसको कैसे ड्राइंग करते हैं, वी विल सी कूलिंग
और
डाउन ऑफ द।
टर्मिनल अगर टर्मिनल की तरफ से निकलता है सर तो फिर एंटी फ्रीज डालेंगे उसमें।
नो, वी
अगर
शुड नॉट, वी शिप शुड नॉट डू विदाउट द,
टर्मिनल ओनली सर।
या टर्मिनल विल डू कि यस, अगर उनके पास है देन दे कैन सी, दे कैन डू एनीथिंग। सो फिर वो सारी कार्गो की स्पेक्स चेंज हो जाएगी, वही हमें स्पेक देगा कि ये सैम्पलिंग तो है ही है, भाई दिस टाइप ऑफ कार्गो आपने दिया, उसके अंदर कुछ भी है वट एवर दे हैव पुट। सो बट दिस इज अगेन जस्ट फॉर द नॉलेज की है, अगर ऐसी चीज़ है इट इज़ पॉसिबल कि हाइड्रेट फॉर्मेशन को रोकने के लिए। सो सिंपल, वी ऑल्सो नो, अभी सो मेनी टाइम्स वी सी ऑन द, आई थिंक इवन ऑन टैंकर्स इफ यू सी दिस पीवी ब्रेकर और अदर डेक सील एंड ऑल दैट, उसके वाटर में भी हम एंटी फ्रीज डालते हैं so that it doesn't freeze, isn't it? So this much knowledge, so as it is
यस
we
सर,
have case,
ग्लिसरीन सर
yeah, in case there is no,
उसमें ब्रेकर।
yeah, पीवी ब्रेकर में कि पानी है तो उसको फ्रीजिंग से बचाने के लिए, तो आइडिया यहाँ पे भी है कि अगर कार्गो में पानी आता है शुड नॉट फ्रीज, फ्रीज होगा तो हाइड्रेट, जैसे यहाँ पे इन दिस केस दे कॉल इट हाइड्रेट फॉर्मेशन। सो अब ये सेल्फ रिएक्शन पॉलीमराइजेशन लाइक केमिकल्स कि अगेन which can be dangerous. So polymerization normally produces heat which accelerates the reaction. The small molecules, monomers joining together and forming a bigger molecule, what we call the polymer. And ये जो reaction है, it is again अपने आप ही self reaction है कार्गो के साथ, and it's like a chain reaction if it starts, and then it can produce lot of heat, temperature, pressure, which can be dangerous for the tanks. So again the IMO code requires cargoes which may self-react either to be carried under inert gas blanket or to be inhibited. वहाँ पे भी हमने देखा कि yes, the shipper has to basically see this, that if this type of reaction is possible, so they should add inhibitor so that this reaction doesn't take place and the cargo can be safely carried. And in the later case, if it is added, उसका certificate must be given to the ship stating the quantity, name of the inhibitor added, and the date it was added and how long it is expected to remain effective. So of course all these things are well planned. Ship की voyage कितनी लंबी है, if there is a possibility of any delay, अब ship तो ship है कि yes, sometime berthing delay हुआ, यानी इनिबिटर की लाइफ खत्म होगी, शेल्फ लाइफ अभी इतने दिन है, उसके बाद फिर there are chances of reaction taking place. So this is well taken care. The action to be taken should the voyage exceed the effective lifetime of inhibitor, तब क्या एक्शन लेना। तो ये भी शिपर जो कार्गो को मैन्युफैक्चर कर रहा है, ही नोज एवरीथिंग, ही नोज द मैक्सिमम, एनी टेम्परेचर लिमिटेशंस इफेक्टिंग द इनहिबिटर, तो सब हमें टोटल डिटेल इंफॉर्मेशन हमारे पास शिप के पास होनी चाहिए। यार इसके अंदर इनहिबिटर ऐड किया है, उसकी लाइफ so many days it is, and temperature. Normally there should be no need to add any inhibitor to cargo during the voyage, but if it should become necessary, any such addition should be made according with the shipper's instructions. ये भी हो सकता है कि चलो voyage लंबी हो गई, anchorage मिल गया, then they may say कि okay you can do this, but again with their instructions, not on our own. Or possibility क्या, if the ship is anchored in still conditions, cargo should be circulated daily to ensure uniform circulation concentration of inhibitor. तो ये सारी instructions रहेंगी. Normally केस आता नहीं है, but in case the cargo is such that it is getting affected, so उसकी circulation भी possible है. Certain cargoes which can self-react, ethylene oxide, propylene oxide, but which cannot be inhibited also. उनमें दूसरी problem have to be carried under inert gas. So care should be taken to ensure positive pressure is maintained in the inerted atmosphere at all times, and oxygen concentration को basically कम रखना में, never exceeds 0.2% by volume. So this is another case in case certain liquefied gases you cannot add the inhibitor, so then it is to be carried, means oxygen को आपने निकालना है ताकि reaction ना हो. Same reaction with air, cargoes react with air to form unstable oxygen compounds which could cause explosion. So यहाँ पे भी code requires these cargoes to be either inhibited or carried under nitrogen or inert blanket. And of course care should be taken to observe the shipper's instructions. So ये तो important है ही है. Reaction with other cargoes, normally we do not mix. ये तो है ही नहीं कि we will mix the cargoes, and if we know, we will take extra precaution कि यार कहीं mixing ना हो. Certain cargoes can react dangerously with one another, and they should be prevented from mixing by using separate piping, venting system, separate refrigeration equipment for each cargo. अब reliquefaction भी करते हैं. Lot of cargoes need reliquefaction because of this vapor generation. वो vapor generation है उसको so that to control the excessive pressure. So we reliquefy these vapors back into the liquid and put it into the tanks. So उसके लिए भी कार्गो जो हैं मिक्सिंग टाइप हैं, if they react तो उनको भी अलग अलग सही करना पड़ेगा. यहाँ पे भी care should be taken to ensure the positive segregation is maintained. लीकेज नहीं होनी चाहिए, मिक्सिंग नहीं है. कार्गो तो गया, it can be dangerous also. So establish whether or not two cargoes will react dangerously. Data sheets each cargo should be consulted. So again we are back to same thing. Yes, whenever we are carrying any cargo, so we don't have to be scientists, but we have to be aware. क्या इसकी precautions क्या हैं, इसके contents क्या हैं, and what all can happen. And then of course once we know these many things, चाहे from the data sheets or from the books, so we know how to handle. Now the data sheet lists materials which should not be allowed to come in contact with the cargo. अभी तो materials के साथ, materials जो है हमारा tank का material, pumps, gaskets, lot of things are inside this thing when we are what we are going to use. So material used in cargo systems must be compatible with the cargoes to be carried. And care should be taken to ensure no incompatible materials are used or introduced during maintenance. Reaction can occur between cargo and purge vapors of poor quality. For instance, inert gas with high CO2 content can cause carbonate formation with ammonia. The reaction can also occur between compressor lubricating oils and some cargoes, resulting in blockage and damage. So ये भी dangerous है. तो इसके लिए इसकी भी knowledge है तो yes. So sometime if you have to do inerting, so अगर CO2 के साथ reaction है nitrogen, the other solution is that pure nitrogen. Some ships have nitrogen generator. So nitrogen can be used as a inert gas. Corrosivity तो सभी के साथ है, whether it is chemical or it is gases or it is the vapors, anything, it can be corrosive. So code requires material used in cargo system to be resistant to corrosion by cargo, and care should be taken to ensure unsuitable materials not introduced in the cargo system. यहाँ पे corrosiveness के dangers है. Corrosive liquids can attack human tissue. दोनों ही हैं, materials को भी है and human body को भी. So we cannot afford to have कि चाहे वो लीकेज हो चाहे कुछ भी हो, चाहे liquefied gas है कि यस उसके वेपर्स भी corrosive हो सकते हैं. So touching, coming in contact should be avoided. And instructions about protective clothing. अब ये दोनों ही शिप्स आप देख लीजिए, केमिकल टैंकर्स एंड गैस कैरियर्स दोनों में है कि प्रोटेक्टिव क्लोथिंग के ऊपर काफी स्ट्रेस दिया गया. एंड आई नो इट इज डिफिकल्ट ऑल्सो, हाई टेम्परेचर पे विद दिस प्रोटेक्टिव क्लोथिंग काम करना विद ग्लव्स एंड ऑल दैट इज नॉट दैट इजी. लो टेम्परेचर इफेक्ट्स, व्हाट वी कॉल अ ब्रिटल स्ट्रक्चर, वो भी पॉसिबल है. लिक्विफाइड कार्गोज ऑफन शिप्ड एट लो टेम्परेचर. So temperature sensing equipment is well maintained, accurately calibrated. Sensing equipment है कि ये भी नहीं है कि temperature lower हुआ तो equipment ही गया. Hazards associated with low temperatures basically is a brittle fracture. Brittle fracture क्या है? Metals. अब यही liquid अगर हमारा deck पे सचा low temperature -100, any liquid if I spray on deck which is made of your mild steel, that structure can crack because of the what we call the brittle fracture. So most metals and alloys become stronger but less ductile at low temperatures. That is, tensile and yield strength increase, but materials become brittle and impact resistance decreases. It's like आपका stainless steel के चम्मच को कभी bend करके देखिए, टक टूट जाता है. Otherwise ठीक है, strength wise ठीक है, enough. So the same thing happens with the normal materials, that they become brittle like a copper when temperature is lowered tremendously. तो यहाँ पे ये केसेस भी हैं. बाकी तो ठीक है, लिक्विड कार्गोस ऑयल्स जो थे कहीं पे भी ड्रिप हो रहे हैं, ड्रॉप हो रहे हैं, चलो कुछ नहीं होता, ओनली क्लीनिंग इज द इशू. अब यहाँ पे तो ये है कि यस, दैट्स व्हाई इन केस ऑफ एनी एक्सीडेंट एंड ऑल दैट, दिस ब्रिटल स्ट्रक्चर इज द मोस्ट डेंजरस थिंग. कार्गो लीक्स, सच अ कोल्ड कार्गो लीक्स आउट wherever it meets, wherever it goes on the hull structure, and उसके ऊपर थोड़ा सा स्ट्रेस आया तो वो टूट जाएगा. So because the reduction in temperature changes the material's crystal structure. Basically होता क्या? I think long time back I have seen on the YouTube also, they have shown very nicely कि एक metal को वो hammer करता है, nothing happens, and then he puts this metal sheet like a steel plate, उसको low temperature, उसका temperature low करते with a very low liquid उसमें वो डालता है. Beautifully to us to observe, to understand कि brittle fracture होता क्या. And उसका when temperature is low so much, -10, -20 या -30 पे लेके जाते, and then when he hammers, immediately the metal sheet breaks into two. So this is, they have explained. Of course अगर आपके पास time है, if you are working on the gas carriers, YouTube has got very good videos to understand how this temperature affects. Basically of course they, वो तो केमिस्ट्री एक्सप्लेन कर रहे थे कि यार लो टेम्परेचर से मेटल को होता क्या. सो दैट्स व्हाट दे से इज द मटेरियल्स क्रिस्टल स्ट्रक्चर. जो टेम्परेचर है दैट चेंजेस द मटेरियल्स क्रिस्टल स्ट्रक्चर. सो इसके लिए इट बिकम्स दैट इट ब्रेक्स इनटू टू. सो नॉर्मल शिप बिल्डिंग स्टील्स रैपिडली लूज देयर डक्टिलिटी एंड इम्पैक्ट स्ट्रेंथ बिलो 0 डिग्री. देखो यहाँ 0 डिग्री पे ही है. सो ऑफ कोर्स द शिप्स का जो स्ट्रक्चर है दैट कैन स्टैंड. हम भी जाते हैं इन कोल्ड क्लाइमेट्स, Russia, East Canada and all, very common, -30 degree is very common. So the ships are designed in such a way that ये जो plating है, it can stand this cold temperatures. So for this reason, care should be taken to prevent cold cargo from coming in contact with such steels. And as the resultant rapid cooling would make the metal brittle and would cause stress due to contraction. So in this condition, the metal would be liable to crack. So this phenomena occurs suddenly, what we call the brittle fracture. So ये भी है इस कार्गो के साथ. But anyway, the ships are designed, हम तो ज़्यादा नहीं कुछ कर सकते. While designing, that time what metals are used, even in the tanks. अगर आप देखोगे कि yes, LNG के जो tanks हैं, so उनके अंदर जो मेटल यूज किया जाता है इनवार, basically it is nickel and steel alloy, so that can stand very low temperatures. So this is basically the whole technology. So however, ductility, impact resistance of materials such as aluminium, austenite and special alloy steels and nickel improve at low temperatures, and these metals are used. Yeah, nickel alloys has a quality, it can stand very low temperatures, nickel and steel. These metals are used where direct contact with the cargoes at temperatures below -5, -55 is involved. Spillage तो dangerous है ही है. To prevent spillage at low temperature cargo because of the hazard to personnel and danger of brittle fracture. जैसे मैंने आपको बताया कि डेक पे अगर आएगा तो there are chances because of the low temperature anything can happen to the steel deck. So spillage does occur, source should be first isolated, spilled liquid then dispersed. वैसे तो immediately vaporize हो जाएगा. Now cool down. Now cargo systems are designed to withstand a certain service temperature. Now if this is below ambient temperature, the system has to be cooled down to the temperature of cargo before cargo transfer. वो भी हम देखेंगे how these tanks are cooled down before loading. LNG, ethylene, of course thermal stress is what we call. LNG तो -160 पे है and you cannot lower this temperature suddenly. ये नहीं कि आप एम्बिएंट टेम्परेचर पे आपके टैंक्स हैं एंड हमने अगर -100 पे करना है तो ठीक है, इट विल नॉट टेक 1 hour 2 hours. So there is again a specification, there is again a condition that at what rate the temperature has to be lowered, maybe about 10 degrees an hour. So अगर मेरे को -100 पे लेके आना है तो about 10 hours तो ship will be just cooling down the tanks. So for LNG, ethylene, stress, the thermal shock caused by over rapid cool down of the system could cause again the brittle fracture. ये भी चीज पॉसिबल है. So इसके लिए जब हमने उनकी कूलिंग डाउन करनी है टैंक्स की तब भी शुड बी एट अ वेरी स्लो रेट. तो आपने इंजन को भी देखा होगा, सेम थिंग इट इज, दिस इज कूलिंग एंड जब engineers when they start their engine in the low temperatures, so they also basically आप देखना they keep the steam on, they keep the things on, that's why their plant is kept on. So just to not immediately start the engine, just to warm up, bring it to the temperature. Suddenly extreme cold से अगर आप you are heating up the engine parts, so वहाँ पे भी वही thermal stress आता है. Ice formation, that is also possible. Low cargo temperatures can freeze water in the system, leading to blockage, what we have seen, the hydrate formation. रोल ओवर, ना ये चीज इंपॉर्टेंट है अभी, इसके ऊपर क्वेश्चन भी है, पूछा भी जाता है कि व्हाट इज रोल ओवर. ना रोल ओवर अगेन इज बेसिकली समथिंग कॉल्ड a layer formation takes place. Now layer formation कैसे take place करेगी, is a rapid, basically if you see any cargo which has got impurities, कुछ ना कुछ तो होगा. LNG is very famous कि जब नेचुरल एलएनजी को एक्सट्रैक्ट करते हैं इट इज मीथेन, उसके साथ प्योर मीथेन तो है नहीं, कुछ ना कुछ और भी इम्प्योरिटीज ऑल्सो कम. सिमिलरली उसको आपने लिक्विफाई कर दिया. सो जो टॉप सरफेस ऑफ द कार्गो है दैट हैज अ टेंडेंसी टू वेपोराइज, तो उसमें से वेपोराइजेशन होगी, देन द टॉप सरफेस बिकम्स मोर डेंसर, कि उसके अंदर से चाहे वो इम्प्योरिटीज थी कुछ ना कुछ वेपोराइज हुआ. सो टॉप सरफेस of this liquefied gas becomes more denser as compared to the liquid which is down below, which is just below that. वो तो normal density पे ऊपर वाला, because of vaporization the top surface becomes more denser. So this is what we call a layer formation takes place, or it is called a stratification. So stratification develops when the liquid layer adjacent to a liquid surface becomes denser than the layers beneath due to boil off. Boil off is same thing, vaporization of the lighter fractions from the cargo. Now this obviously becomes an unstable condition, and ये जो unstable condition है, it has to relieve itself with a sudden mixing. अब ये low density और high density दोनों जो cargo immediately adjacent to each other, they cannot stay like this, so they will suddenly mix. एंड इनकी जो सडन मिक्सिंग है, दिस इज व्हाट वी नोन एज द रोल ओवर. And the liquid hydrocarbons are most prone to this rollover, especially cryogenic. Cryogenic means the refrigerated liquids. LNG, most likely by virtue of impurities. So जो इसके अंदर impurities हैं, they may start boiling off, vaporization quickly. थोड़ी सी भी उसका temperature change हुआ, they start immediately boil off शुरू हो जाते. And the extreme conditions of temperature under which it is stored. एक्सट्रीम कंडीशंस क्या, -161. सो बाई चांस थोड़ा सा भी, अब शिप तो शिप है, एक आधा डिग्री टेम्परेचर ऊपर गया तो बॉयल ऑफ विल स्टार्ट. सो दिस इज व्हाट द basically the phenomena what it takes place, and it is if the cargo is stored for any length of time and the boil off is removed, evaporation can cause a slight increase in density and a reduction of temperature near the surface. So liquid at the top of the tank is therefore marginally heavier than the liquid in the lower levels. And once this layer formation or stratification has developed, rollover can occur. And ये जो inversion है, this will be accompanied by a violent evolution of large quantities of vapor and a very real risk of tank overpressure. अब ये जो आपके tanks हैं which we are carrying liquid or liquefied gases at a very low temperature, उनकी तो strength भी कम है ना, they are not able to stand high pressure. Because they are built like that, they are built to stand low temperature. And low temperature में, like if we are using the tanks which are for fully pressurized ships. Now fully pressurized ships के tank strength is quite a lot. The tank plating is quite thick. They can stand 18-20 bars pressure. Whereas these tanks are built of such a material, they cannot stand high pressure. And if this rollover takes place, तो कभी भी rupture हो सकता. So rollover has been experienced even ashore and may happen on a ship that has been anchored for some time. अब ये भी है कि yes, if the cargo is absolutely stationary, anchor पे कुछ भी नहीं है, ship हिल भी नहीं रहा, so there the possibility is there. अब in these cases, the solution is कि इसको कैसे बचाया जाए? Such circumstances are foreseen. The tank content should be circulated ताकि ये layer formation हो ही ना. That's why this recirculation of the cargo by the cargo pumps to prevent rollover occurring. So rollover can also occur if similar or compatible cargoes of different densities are put in the same tank. तो वो भी नहीं होना चाहिए, चाहे cargoes compatible हैं but अलग densities के हैं, तो ये चीज़ भी हो सकती है. So yes, this is what we have to be careful. So rollover के लिए कई बार आपको orals में भी पूछ सकते हैं कि अगर ठीक है गैस कैरियर नहीं भी किया तो कैसे रोल ओवर का, बेसिकली ये फिनोमिना इट अकर्स दिस वे, एंड इसका सोल्यूशन भी जस्ट टू अवॉइड इन केस वी फाइंड द शिप इज एब्सोल्युटली काम कंडीशन, स्टेशनरी एंकरेज पे है, कार्गो इज नॉट मिक्सिंग अप, सो वी विल रिसर्कुलेट द कार्गो. चलो ठीक है, चाय पी लें, टेक अ ब्रेक फॉर अ टी बिफोर वी स्टार्ट द नेक्स्ट गैस कैरियर टाइप्स.
Yes, sir.